Very good morning, one and all. I, Dr. Pramod Ingre, Principal at Nanvilas College of Pharmacy, Pune, presenting the session on steroid nomenclature. The learning outcomes of today's session are: at the end of this session, the students will be able to illustrate the numbering for steroidal structure, classify various steroids chemically, and elaborate the steroid nomenclature. Before we go for the steroidal nomenclature, we should know the introduction to the steroids. Adrenal gland has two parts, adrenal medulla and adrenal cortex. Adrenal medulla is responsible for the release of catecholamines, a major neurotransmitter in the sympathetic nervous system. Adrenal cortex releases three types of hormones. First, the glucocorticoids, example hydrocortisone, which is responsible for the metabolism of carbohydrates, proteins, and lipids. It is acting in the liver. The second is mineralocorticoids. The examples are aldosterone and deoxycorticosterone. They are responsible for retention of sodium in the body. The next are the adrenal androgens, which are released from adrenal cortex, which are the precursors for the sex hormones, estrogens and androgens. This is a steroidal template. This is having the similarity with phenanthrene. The ring ABC is from the steroid template is resembling the perhydrophenanthrene. The steroidal template is the cyclopentano perhydrophenanthrene nucleus. This is the similar part between the ring A, B, and C, the phenanthrene moiety. This is the steroidal backbone. Here we'll see the steroid template. How to draw the steroid template. Ring 1, ring 2, 3, 4. The rings are named as ring A, B, C, and D. The numbering, which is unusual, it is not following the general nomenclature rules. Here, the numbering starts from the ring A carbon atom 1, then the 2, then 3, then 4, 5, 6, 7, 8, 9, 10. So you have seen that from around the ring A and B, the counterclockwise fashion, the numbering is given. Then starting from C, the clockwise fashion, we go for number 11, then 12, then 13, the 14, then again counterclockwise manner from the ring D, that is 15, 16, and 17. This is the steroid template. Now cholesterol. Here we'll see how to draw the cholesterol. The hydrogen at 14 position, then the hydrogen at 88 position, then the hydrogen at 9 position, methyl at 10 position, methyl at the 13th position, then the side chain starting from 17. Then this way the side chain will go till the 27 carbons. Now how to number the system? Now we have seen from 1 to 17 how the numbering is given. Now this carbon which is at the 13th position, the substitution of methyl which is at the 13th position is given the 18th number. Then the substitution of methyl at the 10th position is given the 19th number. Then the substitution at the 17th position is given as 20. Then the 21, 22, 23, 24, 25, 26, 27. This is the basic template for the cholesterol. Uh, cholesterol, this is the structure for 5 alpha cholesterol. Now here it's important to denote the ring junction hydrogens, whether they are having the beta position or the alpha position. Alpha position is away from the viewer and beta position is towards the viewer. So for example, your 5 alpha cholesterol is there. So the hydrogen at the 5 alpha position is at alpha, which is anti to the methyl on the C10 position. So C10 methyl is shown by the solid beige. It is towards the viewer. It is the beta, and the hydrogen is shown by the dotted beige, which is away from the viewer. Similarly, the ninth hydrogen is also alpha, then the eighth hydrogen is beta, 14th hydrogen is again alpha, 13th methyl again it is a beta, and 17 again it is a beta. So this is cholesterol. The distinguishing character of cholesterols are there are two methyl groups at C13 and C10 positions, and the 8 carbon side chain attached to the C17 position. Using the rigid planar orientation for drawing the steroid structure, the basic steroid structure becomes a plane with two surfaces. The top or beta surface is pointing out towards the reader, and the bottom or the alpha surface is pointing away from the reader. Hydrogen or functional group on the beta side of the molecule are denoted by solid lines. Those on the alpha side are denoted by the dotted lines. The 5 alpha notation is used to denote the configuration of the hydrogen atom at C5, which is opposite from the C19 angular methyl group, making the AB ring juncture trans. The C19 angular methyl group is assigned the C19 methyl group is assigned the beta side of the molecule. Similarly, configuration of the 8 beta and 9 alpha hydrogens and 14 alpha hydrogen and C18 angular methyl group denote transfusion of the rings B and C and D. The side chains at position 17 are always beta unless indicated by the dotted line or in the nomenclature of the steroid, 17 beta or 17 alpha. Just as the cyclohexane can be drawn in the chair conformation, the three-dimensional representation for the 5-alpha cholesterol is shown by the figure which is shown on the screen. Although cyclohexane may undergo a flip in conformation, steroids are rigid structure because they generally have at least one transfuse ring system. This ring must be di-equatorial to each other. If one is aware that the angular methyl group at position 18 and 19 are beta and have an axial orientation that is perpendicular to the plane of the ring, the conformational orientation of the remaining bond of the steroids can be easily assigned. For example, in 5-alpha cholesterol, the C19 methyl group attached at position 10 is always beta axial. The two bonds at the position 3 must be beta equatorial and alpha axial as indicated. The orientation of the remaining bonds on the steroid may be determined if one recalls the groups on the cyclohexane ring that are positioned on the adjacent carbon atom, are trans if their relationship is 1,2 diaxial or 1,2 diequatorial, and are cis if their relationship is 1,2 equatorial axial. The compound 5-alpha cholesterol is said to have a trans-anti-trans-anti-trans backbone. In this structure, all the fuse rings have trans diequatorial stereochemistry. In other words, the AB fuse ring, the BC fuse ring, and the CD fuse rings are trans. The term anti is used in the backbone notation to define the orientation of the ring that are connected to each other and have a trans type of relationship. As this arrangement, if this is there, if there is a change in this arrangement, the three-dimensional structure of the steroid is changing and affecting the results. Now the example of 5 beta cyclocholesterol, it has a cis anti-trans backbone in which the ring AB are fused as cis with each other. The term syn is used in similar fashion as anti to define the cis type relationship. The other ring junctures are trans, like for example the ring juncture B and C is trans, the C and E ring juncture is trans. As you can see in the three-dimensional structure also, the ring AB is having a cis juncture, BC is having the trans ring juncture, and the CD is having the trans ring juncture. Now, no natural steroids exist with a syn type geometry, although such compounds can be chemically synthesized. Androsten, if you see the structure of 5-alpha androsten, you have the number of carbons as 19. The distinction characters of androsten are there are two methyl groups, one at C13 position and another at the C10 position. And there is no side chain at the 17 position. Next is pregnane. Pregnane, this is the example of 5-alpha pregnane. If you see here, the total number of carbon atoms are 21. The distinguishing characters of pregnane from that of the cholesterol or the basic structure is there are two methyl groups at the C13 and the other at the C10 position, similar to that of the androsten. Next, there are two carbon side chain at the 17th position. So these are the examples of the pregnane. Next are strains. This is the 5 alpha strain. If you see over here, the total number of carbon atoms are 18. The distinguishing character of strains are only one methyl substitution at C13 position, no side chain at the 17th position. Now it is the time for taking a question. Can you guess hormones from androsten, pregnenolone and estrogen? 5 alpha cholesterol, the example is cholesterol. 5 alpha pregnenolone, the example is progesterone and hydrocortisone. I've asked the question for the same. Next is 5 alpha androsten, the examples are testosterone and dehydroepiandrosterone. 5 alpha estrogen, the example is 17 beta estradiol. If you see in the 17 beta estradiol, the ring A is completely unsaturated ring system adopting a planar configuration. Now, indicating the unsaturation in case of the steroidal moiety for the nomenclature aspect, 5 alpha androst 8-ene or 5 alpha delta 8 androsten. So for here, 5 alpha colis 6-ene assumes a double bond between 6 and 7 position. Whenever there is a double bond between between 6 and 7 position, we have to mention the starting letter 6. If there is a double bond between 8 and 9 position, that will be 8-ene will be there. For example, 5 alpha androst 8-ene, assuming the double bond between 8 and 9 position. Now, if however a double bond is formed at any position other than the next highest number, or if it can be drawn in two different directions, the end of the double bond also needs to be specified. For example, 5 androst 8 inside bracket 14-ene indicates the double bond between the 8th and the 14th position. Double bond are also indicated by a capital delta with the positions of the bond specified by the superscript number. 5 alpha delta 8 14 androsten. Note the "-ene" ending, which lets you know that there is a double bond in the structure. So there is double bond is between the 5 alpha 8 position and 14 position. So here it is delta 8 inside bracket 14 is mentioned. We'll see the two examples for the nomenclature. Uh, First, cortisone. It is having 17 alpha 21 dihydroxy 4 pregnine 3 11 20 trione. Now 17 position, the hydroxy group which is there, it is at alpha position, hence the 17 alpha is denoted over there, and 21 21 position is also having a hydroxy. Then there is a double bond between 4 and 5 position, indicating the 4 pregnine, so 4-ene is written over there. Then there is a double bond O that at 3, 11 and 20 position, hence the name 17 alpha 21 dihydroxy pregnine 3, 11, 20 trione. The other example is of 17 beta estradiol, estra 135 10 triene 17 13 17 beta diol. The ring A over here is a planar ring system. There is a hydroxy at 3 and 17 position. The 17 hydroxy as beta, hence the 317 beta diol. There is a double bond between the ring in the ring A, 1 and 2 position, then 3 and 4 position, and 5 and 10 position. Hence, estra 135 10 triene. So the nomenclature goes in this way. With this, we have ended the nomenclature of steroid. Thank you very much. Thank you.